Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today with some really interesting information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it on demand. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And we'll take probably around 5 or 10 minutes near the end of the presentation and go through audience questions. And finally, we are doing a drawing at the end of today's presentation for 3 $50 Amazon gift cards. So stick around until the end of today's presentation. Hopefully you'll be one of our lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is using AI power automation for high performance data pipelines in the cloud. Our speaker today is Alejandro Fernandez, who is a software engineer at Unravel Data. Hi, Alejandro, how are you? Thanks for joining me today.
Hi, Charlene. Thank you for the introduction, and thank you for having me.
Excellent, excellent. Well, I'm going to just put myself on mute and let you get right into your presentation.
Okay, perfect. Again, thank you so much, and welcome, everyone. I'm really excited to share with you some of the things we're doing here at Unravel Data to basically make the cloud more efficient using AI automation for all of your Hadoop workloads to get more insights. Quick background into myself. So I'm a principal engineer at Unravel Data, and previously I was at Hortonworks for 3 years, helping them work on Apache and buries, which is the Hadoop cluster manager. I've also contributed to Hive and Airflow, and after that I was at Airbnb, hoping to manage their data infra team, which focuses on storage, security, and also ETL tools like Airflow. So now I want to focus on the cloud and how to make migrations easier for customers, help them save money, because it's a very long and tedious effort. And so with that, let's begin, right? So first of all, is the cloud even a good deal? So we've all heard the stories about potential savings, but we've also heard some of the horror stories. So for example, many of you may have read the article that Lyft is actually planning to spend a budget of $300 million over the next couple years. So from 2019 to 2021, and they must at least spend $80 million per year. So given that the volume of potential spend on the cloud is potentially enormous, how do we ensure that we're actually spending the amount that we want and don't get sticker shock once we get our bill, right? So with that, I'm gonna go over how to plan your cloud migration, how we can use tools to automate the triaging, your workload management and make it more efficient while saving money on those resources, and basically having a 360 view of how to make cloud more visible, right? Okay, so first I want to start out with, what are the problems that are different on the cloud versus on-prem sometimes, right? And those can basically stem from the fact that it's a more complex environment, primarily because in a lot of the times, the clusters are ephemeral, so you may not get access to your logs unless you retain it or you store them, say, in S3. On top of that, there's more coordination that has to happen. So you've got a team of operation folks and a team of application developers, data scientists, and data engineers, and they're all running on a big data ecosystem. But you may hear these problems happen over and over again. And that's that there is problems on both the application side as well as the operation and the infrastructure side. So for example, on the app side, it could be that the user is writing a bad query. It could also be that the application is failing today, it's slow, there's lag, there's contention, resources that are not playing well together in the environment, right? And so all these things make it much harder to figure out what is actually happening on the Hadoop cluster. On the operations side, you've got a team of infra folks trying to figure out, is their budget basically getting the most bang for their buck. And what typically tends to happen is that there may be some finger pointing, from both sides on, why is the app running slow? And at first it may seem like it's the developer's fault, but then they identify it as something on the infra side and keep going back and forth, right? That's a very difficult problem to solve, especially on the cloud, because there's more access control. So for example, only certain developers can look at some views. The infra team is the one that's in charge of row access and controls and permissions and doing things like cluster management, right? So because we've created all these groups and teams, it's harder to get 100% visibility into what's happening. And so you basically need a PhD to figure out what's happening. And there's no simple answer to how to fix these things. And so the current approaches that exist out there are pretty tedious because you've got a very complicated system that's got thousands of log files to dig through, right? And these files are in different machines. You've got to do correlation. So for example, what happens if you've got an error on a data node and you want to correlate that with something that's happening on node manager, which could also be failing due to like a faulty disk somewhere, right? And so it's pretty hard to get all these things together. The other approach is to basically come up with monitoring tools. There's a whole bunch of them out there. The general feeling is, however, that they provide thousands of signals and it's really hard to correlate what those are. So you've got tools, just to name a few, like Splunk and Datadog, and if you're coming from like Umbar, you've got Umbar Metric System plus Grafana, and then the old school Nagios and Ganglia to do all this surfacing of metrics, right? But you're still leaving it up to the individual data scientist or the infra team to correlate these points of information and figure out why is my application failing on the cloud, right? So it's not an easy problem to solve at all. Once you combine that with the fact that the Hadoop stack is actually fairly complex because it's meant to be plug and play. You can replace a lot of the components that are interoperable. So for example, on the storage side, you've got HDFS, you've got different file systems like RC or C, Parquet, and Avro. You can use S3, and you can even use a hybrid architecture, and that's just the storage layer, right? When you talk about scheduling, you've got Yarn and Mesos for ETL tools that extract, transform, and load your data. You've got a ton of different options out there. I'm just going to name a few, but you've got Impala, Hive, Presto, etc. And so you can basically pick and choose how you want your stack to look like. And the fact that there's so many different options available adds so much more complexity to the problem because everything has to be interoperable, right? And when you're actually migrating to the cloud, it's really hard to do a proper cutover, right? No one really does that because they need to keep their business up and running for continuity reasons. And so it's not uncommon to move into a hybrid architecture in which in the first couple of, say, months, you've got data being copied over to, for example, S3 as well, and you're running the same jobs in both the environments, cutting it over, doing some testing, and then once you're finally happy, then that whole tenant or department or application is running natively on the cloud now, right? But the hardest part is to come up with a single correlated view on how all these pieces fit together, regardless of what stack you're coming from. So whether it's Cloudera CDH, Hortonworks HTTP, or their new unified release, which is called CDP, or even MapR, right? Plus some of the other vendors out there like Amazon, EMR, Databricks, so on and so forth. So let's talk about how Unravel actually solves these problems. And I'm going to do a deep dive on some of the automation pieces, AI models, things like that. So at its core, we plug into the Hadoop ecosystem in a very lightweight fashion. We essentially have lightweight sensors that send some data over. So for example, if you're running a Hive query, we actually get that query and the execution plan. Once a job finishes, we capture the yarn container logs, for example. And so we have thousands of these little signals of information, and we piece it together. We ingest it through Kafka. We run it through our tuning engine, which is a combination of artificial intelligence models. It's a recommendation engine, and then we use that to drive insights. What the end user actually sees is a single pane of glass that provides dashboards across all of the services in their Hadoop cluster. It's a pretty common feature, which is auto actions. So for example, if you detect that an application, a yarn application is a problematic one because it hasn't finished and it's causing some problems and it won't let a very critical application finish in time, how do you kill that bad app and let the other one finish, right? Or how do you move it to a different queue? Plus things that like, alerts that are actually meaningful, that isn't just a signal of like, a CPU over 70%, right? That isn't necessarily a bad metric, but it's not a good indicator of what the load on the system is and if it's able to keep up, right? Plus things like reporting and config recommendation, how you can be tuning your system better. So some of the problems that we solve are in the space of APM. And APM stands for Application Performance Management. So it isn't just performance management that we do. It's more than that. It's basically giving you a unified view. It's correlation, it's alerting, and it's even planning and migrating how to convert your jobs that are running on-prem to the cloud. A big aspect of that is how do you deal with the resources and optimizing for cost, right? When you're running an on-prem cluster, if you're using, say, bare metal, it's really hard to come up with what the actual cost is, right? Because that was a one-time cost. So what is the recurring cost? If you're using, say, EC2, yes, you do know, for example, your monthly or your annual cost, right? But potentially, you don't really know how much you could be saving if you were to basically split up your cluster or your monolith cluster into multiple smaller ones that are running on the cloud. Or what if you want to move just a subset of those jobs, depending on the tenant or the application type? So there's a ton of variables out there that can inform our decisions about, which cloud provider to move to, why. And probably the easiest thing to get started with is troubleshooting and root cause analysis, right? So the Hadoop ecosystem is already complex enough. And typically what tends to happen is that you have data scientists that are very good at coming up with, predictive models, writing, whether it's, Java, Scala, or Python, right? But they're not experts into what's the reason why a job failed. The reason being that requires a deeper knowledge into the infrastructure, how the services are running, alerts, etc. And so that's why you have this back and forth between the data scientists and the maintainers, the infrastructure. And sometimes the answer isn't really known until you bounce back a couple of times, right? So it's a very complex problem to solve. So what we do is basically try to take out the guesswork out of managing your Hadoop system. So when it comes to resources in Yarn, we will do automatic queue analysis and auto actions like moving jobs to a different queue. We can even do Yarn queue recommendation. And the goal of this is to remove contention, right? Contention itself isn't really easy to see since there's no single button that says, hey, your job is running slow because this other app is using all the resources, right? The other thing that we do is performance recommendation. So we have a model that basically can tune your job to achieve a desired goal. And I'll talk about that a little bit more later. Whether the goal is to optimize cost or reduce the runtime. The other really big aspect is how do you optimize on the cloud, right? And so I've heard from multiple customers that for them sometimes the goal is basically just migrate as quickly as possible and ensure that all their apps are working regardless of how much you're paying for on the cloud, right? And so for them uptime is extremely important, as is things like reliability, and that's just some of their KPIs. Other times, especially if you're either starting out or you care more about cost, you definitely want to be right-sizing your VMs. And so it's pretty easy to over provision for peak capacity, right? Um, and so we provide some ways of essentially predicting what your workload looks like, and so that you can take advantage of elasticity on the cloud. So depending on what your workload looks like, you can take advantage of only provisioning certain VMs. So for example, you have a reserve price for X number of VMs, which is sort of your baseline. And then we will do some analysis on your trends to figure out, okay, it looks like, for example, every Monday through Friday from, say 10 a.m. to 4 p.m. looks like you have a spike in activity. So let's account for that, right? And whether you can benefit from those extra VMs using, spot pricing or something else, right? The other really important thing is identifying which apps are really suitable for the cloud. The important point that the cloud gives us as an advantage is that we can control exactly what the flavor is. So how do we balance the scale between, for example, VMs that are more CPU heavy or memory heavy, depending on workloads. So if you're running a Storm application, or even like a Spark, that may be more memory intensive than say like something like Kafka, right? Which may only need a certain amount of resources, right? So we can basically identify which apps are more suitable for the cloud based on the resource utilization. And last but not least, we really focus as well on event management. So even the collection of every single sensor out there, right? So these signals, your logs, to have it in a single place is a huge time saver, especially for the teams that spend a lot of time looking at logs since they're not in a single place. And yes, there are tools out there. You can use like the Elk Stack, which is Elasticsearch, Logstash, and Kibana. You can also use Splunk, and even distributions like CDH and HTTP can ship Solar, right? But that just makes it easier to find the log. It doesn't really do correlation for you. So I'll talk about how we integrate as well with alerts and even with services like Slack. Okay, so the next couple of slides, I'm going to deep dive into the actual AI model of root cause analysis, right? So the source of information is basically, you've got log files, whether those are, your container logs, or they could be, if you're running a Hive job through Beeline, that's going to appear in Hive Server 2, or the Spark executor logs, right? And so each one of these logs has a template that we can use to extract the meaningful information out of. And think of that as basically error codes, the stack trace, right? And we can convert that into a feature vector, right? These stack traces essentially have words and codes, and we try to use that to come up with a predictive model of what the recommendation is for why that job failed. And so a typical data scientist can actually identify those root causes for us, and that's how we've trained our predictive model. So I'm going to talk more about that in a second. But we've looked at different types of models, so both logistic regression and random decision forests. The reason why we chose these two is that, for example, with logistic regression, since there's a limited number of possible values for what the outcome is, so if a job fails because it can't find a table, right, then there's only a limited number of reasons why that table could be missing, right? In some ways, it's the error code could even be telling you exactly what that is. And the reason why we also used random decision forests is that the importance of the words matter. So the stack trace itself can tell you the reason why this job failed is that the table is offline, right? And so words like Hive, table, offline, they all have some meaning and importance next to each other. And so basically it's a word problem when trying to find out what are the meaningful associations. And so given a stack trace, what is human readable message that we can display to someone that's going to let them know how to go ahead and fix this. And there's two other algorithms that basically can give us accuracy results on which one of these two is better. The first one is called TF-IDF, which stands for term frequency inverse document frequency. And basically, this is used to find out the relevance of a word in a corpus. And there's multiple different implementations of this algorithm based on whether you want, a binary yes or no, or do you want log, number of documents, etc. But basically, this is useful to identify, given an entire stack trace or log file, what are the most meaningful words, right? So for example, timestamps aren't necessarily very meaningful. If you have a document like a book, for example, then the word the and end appear very, very often. And so those have less meaning because they appear so often, right? The second strategy is called doc2vec. And basically it creates relationships between words, right? So it can identify things like, a database is more akin to a table, which is more akin to, say, a partition, right? Than some other word, like, for example, file format, right? And it can also identify relationships that are opposite of each other. For example, the word stop and start are antonyms, right? And so we can use these things to come up with how to create a meaningful message, right? So we ran our model on actual logs and recommendations from scientists, and so we can turn an error failure, like a root cause, into a really easy to read recommendation, right? So this is huge, and I think it stems from the fact that the people writing these tools, like Spark and Buries, myself included, we try to make things very, very specific. And so the error message is basically like, what is at the finest, most granular level, the root cause, right? However, the end user isn't going to really understand what that means, right? So sometimes you have to take a step back and use all these signals, the entire stack trace, the entire log, and multiple logs, come up with a really, really easy to read recommendation. So that's how we use AI to improve the triaging and root cause analysis. Okay, the other way we use AI is for application tuning. And it turns out that this is actually often by trial and error. So we first start out with a goal, right? And so the goal could be, given a Spark application or a Hive job, I want to reduce the duration, or I want to reduce the resources. And notice that some of these can actually be competing goals. So what we do is we have the concept of a session in which we can use the some heuristics, like depending on some configs. And once we combine that with information about every other Spark job that you run on the cluster, and what configs that they use, what was the actual end result, or so what is our feature vector like, right? So things like duration, memory, amount of vcores used, right? We can use all these things to basically infer what's the next config we have to go tune. And so during a debugging session, we will try to optimize for one of these goals. And so the user may specify, okay, I want you to try up to 4 times to optimize this application. Or instead it can say, I want you to try at least 3 times, but stop until the incremental benefit is no more than, say, like 2%. So basically stop trying because every single time you try, you're actually taking away resources from other jobs in the cluster, right? And so it's this cyclical model of looking at what your current goal is, finding out the current performance, and then changing some of these configs. And so an actual example here is the very first time the application failed because it had out of memory issues, right? And so when a data scientist actually sees something like that, their first instinct is to actually try to increase the available memory. It turns out that's actually not always the best solution. It could be that, for example, like the shuffle partition is actually set to a bad value. And so because the error message made it seem like you had to increase the available memory, you're now basically increasing the pool for that job, the amount allocated, and basically you just decrease the amount of available resources for other jobs in your cluster. So what seemed like a good thing for this job is actually globally detrimental for the entire system. On the second run, we actually fixed the config, so the job is actually running now, and notice that the duration is 4 minutes. On the third attempt, we got to the optimal point, which is 1 minute and 3 seconds, and we noticed that even after making a couple of other changes, we don't really get to improve beyond that, right? And so we don't really know yet if this is a global maximum or just a local one. But as far as the user is concerned, their application is, it's meeting SLA and it's running pretty optimal already, right? So from 15 minutes failing to just 1 minute passing, that's a huge turnaround, right? Okay, so next I want to talk about cloud migrations. And so my colleagues and I, we submitted an abstract to the CM Sigma conference, and that's going to be in July. And so you can read the whole paper there, but it basically describes the model for how we do cost optimization when migrating from the cloud to on-prem. So I'll talk about that in a second. But the very first thing you do when planning a migration is to first identify, what does your current stack look like in terms of your usage, your trends, resources, etc. And so we basically built this, flexible and abstract, class that can connect to whatever on-prem service you're using. Right now it's Cloudera Manager, on buries, MapR, and we deliver insights into what is your heat map. So for example, all of these on-prem systems have metrics for example, give me the CPU utilization for every single host or the memory utilization. And so we basically aggregate this data across our hosts, and then we slice and dice it into, say, a 24/7 heat map to figure out, what does the trend actually look like. So for a company that's very ETL heavy and predictable, that may turn into something where it's like, Monday through Friday, 10 a.m. to 4 p.m., though that's like peak, right? And you may have a couple of, ad hoc jobs here and there, but those may be more unpredictable. The next step is to actually plan your migration to the cloud. Sorry, guys, give me 1 second.
Well, Alejandro is taking care of his unannounced visitor. I just want to remind the audience that we are taking questions from you guys. If you have any questions for Alejandro, please go ahead and use your GoToWebinar control panel and submit your questions. We'll take a few minutes after his presentation and go through those audience questions.
Yeah, sorry about that.
No, that's all right. Go right ahead.
Okay, so the next step is actually planning your migration, right? And that entails, picking a cloud provider, which VMs are appropriate for you based on your workloads, and even identifying which apps are best to migrate to the cloud. Once you actually start that process, and I explained before that it's, multiple months worth of work, and for that reason, it's very common to first, have the data, say, for example, also on S3 or ADLS, and basically start porting them over one by one, or tenant by tenant, right? And so we'll do all of these things for you. So one thing I do want to mention as well is that the goal of this is basically to be able to take any on-prem cluster and go to any cloud provider, as well as be able to move between different cloud providers. So whether you're using Azure, HCI Insight, Google Data Proc, or EMR, right? I think for the most part, all these have the same set of services. There's some slight differences here and there, but for the most part, if an application, let's say it's Impala, right? As running Impala, then if you want to migrate to something like HCI, which is using Hive, then there is some small level of risk that it's not going to work. But for the most part, as long as it's SQL-esque compliant, and it should be okay, right? And so we also identify some of these potential risks from moving different application types, right? You've also got to pick what strategy to move to the cloud to. So the easiest one is called lift and shift, which is I want to take whatever on-prem hardware resources I have and get the exact same number on the cloud, right? There's another strategy called usage-based cost reduction, which aims at identifying what is the current utilization that I have, take the average, for example, and based on that, determine what is the optimal number of VMs I should have on the cloud. And the last one is called workload fit, which actually looks at the usage patterns and determines if you can split a monolithic cluster into multiple ephemeral clusters, each one potentially optimized for a different goal, whether it's all of your Spark jobs on one cluster or anything that's like very CPU intensive in a different cluster, right? Even if the applications are running during different times. Okay, and of course, the big picture at the end is what are the potential savings? So with that, I'm gonna actually do a quick demo. Okay, so this is our playground, which is used for demo purposes. And I can actually, when I run this report, it plugs into whatever cluster management tool you're using, like Cloudera, Buries, or MapR, and will identify how many hosts I have, what's the number of cores, memory, disks. Also, what does my CPU utilization look like over a period of time? Same thing with memory and this heat map, right? Next, we actually have a migration strategy. So let's actually do a deep dive on this. So the lift and shift strategy actually aims to use the amount of resources allocated for that host. So if this host has 16 cores and 32 GB of RAM and 512 GPU of disk, when I run this report and I pick a cloud provider, I'll pick Azure, and I can optionally here pick a subset of different VM types, right? And each one of these has again different specs, right? So the recommendation that we give is based on the capacity. So last time I ran this report, it was on EC2, and it suggested that the VM that best maps to this particular host is a C4 8X large, right? So it's going to meet or exceed every criteria. So it must have at least 16 cores, at least 32 GB of RAM, and at least 512 GB of disk, right? And that's the cost of that VM. We've actually improved this feature further so that you can save your VM preferences and it's aware of multiple regions, since the price does depend on the regions and whether you want to use a different storage system. So if you're using EC2 or EMR, how do you actually convert your HCFS system into storage, right? If you're one really simple strategy is to put everything on S3, but that has some risk because S3 is not it's not immediately consistent. It's eventually consistent. The other approach is to essentially replicate HCFS on your EC2 setup, which would be, for example, to just attach more and more disks, right? So that's the EBS story, right? So you save these VM preferences and you run your report, and it's going to give you the optimal mapping. The other strategy is cost reduction. And notice that there's a column here called actual usage. And so we look at the average utilization of this host over a period of time and figure out what is it actually using. So if you've got something like, for example, Hive Metastore, right? Hive Metastore, whatever host is running that component is going to be, say, more CPU heavy. But if you have something like, for example, Yarn Resource Manager, maybe that's going to be more memory heavy. And so the topology or the components as well that are running on that host matter, right? And so each one may have a different recommendation when you pick these VM types. So notice that the cost of lift and shift is $246. For cost reduction, it's $133, since we don't need as beefy VMs. And the last strategy is called workload fit. So we use the heat map to figure out, okay, what is the, say, 90th percentile? So in order for me to meet 90% of all of my workloads, I need, say, roughly, 2078 vcores. Um, so in order for me to meet 90%, let's go hit 90%. So here's how many vcores I need. And we literally go through every single, and choose two combination of VM types just to make it simpler. And consider, okay, with these pairings, can you meet that amount of required memory and CPU? And we try to do so in a way that reduces the cost. The reason why this is important is that if a customer cares more about saving money, they may be okay with, say, allocating just enough for 95% of all apps if it has a huge reduction in the cost, right? And so this is typically going to be linearly decreasing, or maybe like even exponentially decreasing depending on what the workloads look like, right? Trying to meet 100% of all of the workloads, that could turn out to be very, very expensive. Okay, the next thing is you want to identify which are the really bursty apps that are good candidates to move to the cloud. If an application runs pretty consistently with the same amount of memory and CPU, then you can pretty much allocate a reserved capacity for it, and then you're fine using on-prem hardware, right? But if you detect that you've got lots of apps that are bursty in nature, and then those are excellent candidates to move to the cloud, primarily being because on the cloud, you get to basically pay only for what you use. And so we intercept every single job that's run on the cluster, and we can even plug into ETL tools like Uzi and Airflow to detect what these patterns look like. So for Uzi, it's called the workflow. For Airflow, it's called the DAG. We can look at these DAG runs over time and figure out, okay, is the amount of resources that this job or workflow is using increasing over time or decreasing, or what does the trend look like? The same thing with duration. And so this is really useful to identify how do you want to slice and dice it? Either your workloads by the user, for example, like what if I'm a bad user and I'm always submitting apps that are consuming like all the resources because I happen to have admin privileges and I can change my yarn queues, right? Or what if the marketing team is running some jobs at the same time as the finance team and that causes some contention? So you can try to figure out who's going to give you the most bang for the buck. And so whoever, whether that tenant or department, right, has the highest variation of utilization for, say, TPU or memory, those are really good candidates to move to the cloud first. This particular report is a chargeback. So we can historically look at everything they submitted and how much it would cost to run on the cloud. Okay, so I briefly talked about this stuff, which is the fact that our cloud migration discovery report is aware of multiple cloud platforms, right? So AWS, Azure, Google, it's region aware and does take different storage types into account. So I talked about this. And by the way, notice that the workload fit cost is much, much cheaper than the other strategies, right? Okay, the next thing is you actually want to track your cloud migration. In the on-prem world, all right, if your application was passing, we knew exactly how much time that was taking and what amount of resources. We want to make sure that by moving to the cloud, we're still meeting our SLA. And so we have a view where we can compare the same application in multiple environments and ensure that's actually working fine. And so earlier I talked about how do you optimize your applications using the ML models and sessions, right? And so it's feasible to basically, once you move your job over to the cloud, infer what do I need to go change? So we can look at metrics for your number of containers, your vcores in memory, and see what changed on the cloud. Keep in mind as well that whenever you're migrating from on-prem to the cloud, your configs are obviously going to be different. And so you may not have the same, topology to begin with, the same hardware specs. And so it's really important to find out what knobs you have to go change. Sometimes those can be a cluster-wide knob. So for example, change the config for, like the yarn scheduling algorithm, or I want to go change this queue to be FIFO, right? Instead of like fair scheduler, right? Other things can be application specific. So for a particular application, maybe running on the cloud, um, it's optimal to change, for example, like the number of the shuffle size of partitions or the amount of memory, right? Because it's going to run a potentially different hardware. Um, so I also want to talk about service compatibility. So obviously, a migration itself is not an easy task. Um, and the more services you have, the more custom it is. If you've got, local builds or you're forked from Apache, it's much harder to do this, right? And so what we do is we have an option to identify several cloud providers. So whether it's HC Insight, which is actually running underneath the hood, HTTP with Ambari, or you've got EMR, which again has their own version, and Google Data Platform also has their own version, but they've also got services like Airflow or Composer, as they call it, as a service, right? It's not an easy picture to stitch together. And so we identify from your source stack what services and version you're running, what the actual usage is. And we basically have a directed graph with weighted edges, so strong and weak. And we can use that to identify what is the best possible migration for you. So think of a customer that's running, I'll just pick, HCP 2.6, right, with Ambari 2.5, and they have a ton of services listed here. Or in this case, it's CDH, right? But for example, Impala is more compatible with Hive than say Presto, right? Whereas like Uzi has an exact match on EMR. But if you wanted to convert all of your Uzi workflows to say Airflow, which is available on Google's platform, that's going to require a lot of work, right? Because Uzi uses jobs in XML format, whereas Airflow, you have to basically rewrite all of your DAGs again in Python, right? So what is the amount of risk associated with the migration? The simplest one that almost everyone is going to have to deal with is what to do with storage, or like the things that are in the bottom of the stack. So with storage, you've got a ton of different options out there. So traditionally, if you're using HCFS, then you can migrate to say Amazon S3 or Microsoft ADLS Gen 1 or Gen 2, and each one of these things has different properties. The biggest difference between S3 is that obviously the cost is going to be lower, but also you're not going to get an immediately consistent system. And so you may have to come up with a way to basically have a hybrid architecture, or come up with your own, VFS file system implementer to try to, do some of these asset properties. Right. So this is a diagram of what it looks like on AWS, and we also have it running on HC Insight. But on AWS, what's important to notice is that you have execution engines or SQL-esque engines like Athena and Redshift, and the fact that we built these things already and they work for Hive and Impala and Hive on Tez and Hive on MapReduce and Hive on Spark means that at its core, all of these engines have a couple of things in common, right? And so adding support for a brand new SQL-esque engine isn't actually very, very difficult. And so we recently added support in preview for Redshift and Athena. What's difficult is that each one of these vendors has drastically different offerings. The metadata layout is different, or file formats, or the fact that they each have their own security model. So for example, on-prem, you're typically using, say, Ranger or Sentry for authorization, whereas if you're using Amazon, you've got IAM roles. And so there's not a one-to-one mapping, or there's not, at least that I know of, an open source tool that can do some of that transformation for you, right? But we basically sit in the middle of whatever platform you're using, and we intercept all of this, data, and then we're able to actually drive insights. So if it's an application, we can tune it for you. If it's a failed job, we can also provide root cause analysis, plus come up with meaningful and correlated alerts, and not just basically let me know if a particular metric is off by 2%, right? That in itself isn't really a good signal. And so I've been at companies where you've got to do this grunt work yourself, right? So you have to have insights into, is my job failing because of an infra error, or is it because the application is itself poorly written, right? And so a slow or lacking job could be the app itself is bad, could be a bad data node, which has got a faulty disk, and maybe it's the one that's lagging, and you have to go look at job history server to find that out, or maybe even look at other jobs that have been running on that host over time to see that it's a faulty disk, right? It's very difficult to look at these things, right? So here's the chart for how we fit in to a platform like AWS. So Unravel Daemon is in blue, but all the Unravel components are all blue. And so we basically have a daemon that sits inside of the cluster that is essentially a log forwarder, right? The reason being that on the cloud, say 95% of the time, it's very common to have ephemeral clusters. There's one sporting footwear company that spins up, thousands of clusters per day, right, on the cloud. And so what this means is that you can't have Unravel be in those clusters because those are going to be deleted, right? It may be alive only for the duration of that job. And so what this means is that the logs are you need to persist them, say somewhere like S3, but all of your application data, you need to store that somewhere if you want to actually drive insights on those metrics. And so Unravel itself, the server is basically an edge node you can deploy somewhere, and it comes packaged with its own, say a database, whether it's MySQL or Postgres, or its own Kafka brokers, Zookeeper instances, Elasticsearch, etc. So it comes bundled with all these things, and it relies on these very lightweight, unobtrusive sensors. So, for example, for Hive, it's utilizing the Hive pre-exec hooks to detect, what the query you ran was. So, give me the query plan, and also a post hook to figure out, okay, like why, did it fail or did it pass, right? If you're using, say, Oozie or Airflow, we have a sensor that's able to, query those APIs to figure out every single recent application that you've, submitted, show me all of the tasks, the DAGs, all these metrics, and even inspect the logs of those apps to figure out, okay, what is the actual application ID, and then come full circle. So you tie that, for example, the Airflow DAG with the log, with the app ID, with the yarn container log, and then you have this very, very full picture of what happened, right? So you're no longer chasing all these different components everywhere, right? And so I sort of want to end on this note that what really sets us apart is the fact that we have a full stack coverage. So we're really meant to work with, whether it's CDH, HTTP, MapR, EMR, and even like Databricks, right? And the fact that this design is it's a very lightweight sensor means that it's really easy to deploy. That's one of the biggest risks with deploying new apps on your cluster, which is, how much is it going to use up in terms of resources? The next really valuable asset is that fact that we've got, AI models to figure out how do you optimize your job? How do you root cause analysis this particular failure? Plus using this model of, I talked about the three strategies for predicting what your cost is going to be on the cloud. And even if you're on the cloud already, how can you right size your VMs, right? The whole point of being in the cloud is also, once you're there, how do you take advantage of elasticity? So if you can predict your workloads, then you could take advantage of some of those cost savings, right? Especially since the price is very, very variable. So if you paid for some things using the reserve pricing, but you're willing to take, spot or on-demand pricing as long as it makes sense, then maybe you're okay with that, right? So we'll even deliver insights regarding, pricing and VM allocations. And last but not least, there's all these, performance bottlenecks. How do you address, contention in your cluster? How do you actually allow Unravel to take, control of a job, tune it for you automatically, and then once you come back from your lunch break, it'll tell you, hey, by the way, these are your 3 configs recommendations for a cluster, and here's some for this particular job, right? That's a really powerful thing to do. So we had one case study with the customer, and basically for them, they had an incredible increase in productivity, reliability, and they were able to reduce their cost by 60%. So if you go back to what I mentioned at the beginning, with Lyft spending $300 million over the next 2 to 3 years on the cloud, right? If you can reduce your spend on the cloud by 60%, that's a lot of money. And so I think it really makes worthwhile to consider what else you could be doing to save on the cloud. So with that, I'll thank everyone for attending. And if you want to chat more, you can email me or the Unravel team. There's a free trial you can try out, as well as some of the playground demos and all these things. So I'm here available and willing to take some questions.
All right, great. We've gotten some questions in so far, but there's a few minutes. If you've got a question for Alejandro, go ahead and use your GoToWebinar control panel and submit your question, and we'll get to what we can. First question, let's see, who are your competitors?
That's a great question. Pepper Data is probably the closest competitor. They actually, let me take a step back. So the co-founders of Unravel actually used to work on something called Dr. Elephant before, and this came before all of that stuff, right? And so in some ways, Dr. Elephant is the precursor, and it's a tool that does some of these insights. However, it was the very, very early stages, and their findings in developing these tools are then used to shape what Unravel is today. But Unravel isn't just a model for root cause analysis. It's more than that. It's a predictive model for optimizing applications. It's dashboarding. It's reporting. It's alert integration. Yeah, and so there is some overlap with Pepper Data, but for the most part, where we distinguish ourselves is, in terms of our support for multiple types of stacks and their insights.
All right, great. Next question, let's see. Do you support government services such as the Marine Corps, which is going to cloud?
That is a good question. So I'm not on the customer side, so I can't really answer that. But maybe someone from the marketing team or sales team can help answer that if they're on the call.
Okay, great. Well, we can always, you guys will get a copy of all the questions, so I'm sure somebody from your organization will be more than happy to follow up with Martin, who asked the question there. So
what I can say is that a lot of the big banks, they have really big security concerns, and so those clusters are all going to be, for the most part, Kerberized. They're going to be using SSL, and so we support those scenarios. So I can't really imagine a picture where it can work for someone like a bank, but not say for the government.
Mm-hmm. Okay. All right, great. Next question: what artificial learning models do you use?
That's a good question. And so I had a couple of slides on how we do the predictive modeling for both the root cause analysis, and so how we compared the regression model with the decision forests and even some of those word problems. So given a stack trace or an error log, is it better to use, for example, vec2doc or something else, right? So there's a couple things in there, and also some proprietary stuff for the auto tuning.
All right. Great. Okay, well, that is all the questions that we have. So I'm going to uh, keep it open for questions. If you guys have a question for Alejandro, you can go ahead and get it in now. Meanwhile, while we're doing that, I will go ahead and do the drawing for the three $50 Amazon gift cards. So without further ado, our first winner today is Carl Florin. Congratulations, Carl. Our second winner is Thomas Lee. Congratulations, Thomas. And our third winner is Fong Trin. Congratulations, Fong. Congratulations to all three of you for as today's winners of the three Amazon gift cards. Okay, Alejandro, it doesn't look like we have any more questions coming in, so I'm going to go ahead and close things out by just reminding the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you will have the opportunity to do so. Following today's presentation, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go there, just look under the webinar section under on demand, and it should be right there waiting for you. And while you're there, please check out the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Alejandro, thank you very much for giving such a great presentation. Good stuff. Love to hear about that.
Awesome. Thank you everyone for attending, and Charlene, again, thank you for hosting.
Yes, thank you. And thank you everybody for attending as well. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
All right, cheers.